All right, today's lesson is replacing numbers with letters. Last time we looked at having letters and putting in numbers. This time we're going to go the other way and have a number and put in the letter. I got a little confused there. Okay, so first, we're going to do a lot of vocabulary today. So we're going to kind of get some examples and then we'll put it into our own words in our ISN. So just be prepared for the vocabulary. Okay, today's first vocabulary is the additive identity property of 0. Now, if you want to put that as your heading, and then we'll have some examples, and then you can define it. It's completely up to you how you choose to do that. Here's our example. G plus 0 equals G. All right, my question for you is what numbers can we replace G with to make it true? Well, let's try some. Shall we try some? Well, I want to know first, can we replace it with any number? Well, let's see. Okay, let's pick, we'll just stay below 10 just to keep it kind of simple. G plus 0, I'm going to just kind of rewrite it here. G plus 0 equals G. Okay, so if I replaced it with, let's say, 7, that would say 7 plus 0 equals 7. Is that true? Yes, that's true. That one works. Okay, let's try 2. 2 plus 0 equals 2, because all the G's are 2. Is that true? Yes. Okay, as a scientific person, you got to try at least 3 to get it to work. So let's try it. Let's try a bigger number. Let's try 150. I don't know. Plus 0 equals 150. Is that true? Yes. Now this one was fairly simple, but in my own words now, I'm going to put it into my mathematical language how this works. So my vocabulary, my ISN is additive identity property of 0, and that tells me that I can add any number plus 0 and I will get that number. So any number plus 0 equals itself. Itself meaning the original number. So put that in your own mathematical language in your ISN. We've got a few examples to prove it here. Any number plus 0 equals itself. And let's take a look at our second example. That one was fairly easy. This one is another vocabulary, and we'll kind of do the same idea here. I'll just kind of put it next to this one right here. You can put it in your ISN how you choose. This is the multiplicative, it's a big word, multiplicative identity property of 1. So it's very similar, but this is of 1. All right, we have G times 1 equals G. So I'm going to rewrite that so I can use it here. And I'm going to use the X. I don't like to, but I will. All right, G times 1 equals G. And my question again is, can I replace G with any number? Well, let's try some, shall we? Let's try the same ones. Let's just do that just to keep it kind of consistent. You don't have to, but we can. Let's see, let's do 7 times 1 equals, if I'm replacing G with 7, then I have to do the same thing here. 7 times 1 equals 7. Does that work? Yes. All right, I'm going to switch it up now. Let's do 4. 4 times 1 equals 4. Does that work? Yep. I'm going to try a bigger number. I'm going to do 39. No idea where these numbers are coming from, by the way. Okay, 39 times 1 equals 39. Is that true? Yep. All right, it's time to put it in our ISN, knowing your mathematical language. The multiplicative identity property of 1 states that any number, whatever you want to put in there, any number times 1 equals itself. Any number multiplied by 1 equals itself. Put that in your own words in your ISN. Okay, those are pretty easy ones. Let's do another one. This one will be a little bit more complex, but should still be fairly easy. This one is the commutative property of addition and multiplication. There are 2 there. There are 2. So if you want to make two separate ones, that might be a little bit easier. So commutative property of addition, and then your second one, commutative property of multiplication. Two separate ones so that you can kind of keep them separated in your brain there. Okay, let's take a look at the examples. All right, this is the commutative property of addition. We have 3 plus 4 equals 4 plus 3. No variables here, but we're going to replace them. We're going to replace some numbers with variables. Okay, so let's just see what their example looks like. 3 plus 4 is 7 equals 4 plus 3. 4 plus 3 is 7. So 7 equals 7. Do you agree? I do. Okay, I'm going to go ahead and copy down what they have so I have something to work with. Okay, and our first job is let's replace all the 3's in this example with the letter A. So I'm going to have A plus 4 equals 4 plus A. That's really not my neatest work here. Sorry about that. Let's zoom in a little. Okay, A plus 4 equals 4 plus A. Now let's try some like we did here and see if it works. Okay, so let's try, not 3 because they already did 3. Let's try 6. 6 plus 4 equals 4 plus 6. I'm going to go ahead and box these as these are my examples. And then these are my trials. So this is 10. I'm going to put 10 just like I did before. 10 equals 10. That works. All right, let's try replacing A with 1. So we'll have 1 plus 4 equals 4 plus 1. 1 plus 4 is 5. 4 plus 1 is 5. It works. I'm going to tell you it's going to work every time, just so you know. Let's try 80. It's a large number. 80 plus 4 equals 4 plus 80. Oops, I'm sorry. I had 40 there. How was it going to work? Okay. 80 plus 4 equals 4 plus 80. Pretend that zero is not there. Okay. 80 plus 4 is 84. 4 plus 80 is 84. Is that true? Yes. I'm going to put this in mathematical terms. Before we do that, I got another example. Let's try, I'm going to a different color here. Let's try replacing the letter, or the number 4 with the letter B for this one right here. Shall we do that? Let's do it right over here. So we'll have A still, plus B equals B plus A. A plus B equals B plus A. Ooh, now we have two variables. All right, we're going to try some of these. All right, let's replace A with, let's do some teen numbers. Let's do 13 plus 7. Let's do that because it'll be a good round number. Okay, so A is 13. So when we get to A, we're going to do 13. B is 7. So over here it's going to be 7 plus 13. So 13 plus 7 equals 7 plus 13. Let's try it. This is 20 equals 20. Forgot to box this here. Okay, that works. Let's try, we'll just try one more. 11 plus 16. We'll make this a little bit trickier. Work our brains a little more. Equals, okay, now A is 11, B is 16. So we get over here, we're going to do B plus A. All right, 11 plus 16, 6 plus the 1, and both in the ones place is the 7. 1 and 1 in the tens place makes 2 for 20, so we have 27. Let's double check over here. We're going to do that same strategy. I know that this is simple stuff, but this, breaking it down, shows our brain how we know and what we know and how it looks right. Okay, we have a 6 plus a 1 in the ones place. We have a 1 plus a 1 in the tens place. 27 equals 27. Okay, this is the commutative property of addition because we're adding. The commutative property of addition says that it does not matter the order in which you add numbers. It does not matter the order in which you add numbers, as long as they're all addition. Go ahead and put that in your ISN. I'm going to flip my paper over so we have some room down here on the bottom, but it's closer. Okay, let's look at the commutative property of multiplication. Kind of the same thing, but they're using multiplication this time. So they have 3 times 4 equals 4 times 3. 3 times 4 equals 4 times 3. 4 times 3, or 3 times 4, it's 12. 4 times 3 is 12, so 12 equals 12. Okay, so let's replace the 3's with A. We're just going to kind of skip a step here. We're going to replace the 4's with B. We're going to pick any numbers that we want. Let's do ones we can do in our head though. Let's do 6 for A times 3 for B. 6 times 3 equals, I kind of switched that, didn't I? I needed 3 to B. That's okay, because any number should work. So B was 3 times A was 6. Okay. 6 times 3 is 18. I keep forgetting to box that this is my original problem. I'm substituting here. Okay. 3 times 6 is 18. 18 equals 18. Is that true? Yes. Okay, let's try one more because it's kind of just like the addition one. That's why they're kind of grouped together here. Hint, hint. All right, let's try a little bit larger. Let's do 100. Everybody wants to do 100. A is 100 times 5. I don't know if we've used our 5 yet. 100 times 5 equals, B was 5 times A was 100. 100 times 5 is 500. 5 times 100 is 500. And it works. The commutative property of multiplication. It doesn't matter the order in which you multiply, as long as that's all multiplication. So these two are very similar. It doesn't matter the order. Commutative means it doesn't matter the order, as long as it's all the same on one side. So if this is all multiplication over here, no matter how long it is, you can multiply in any order. As long as this is addition, no matter how many there are, you can do them in any order. All right, that concludes our lesson for the day. If you have any questions on those vocabulary terms, I don't think you will, but if you do, please let me know.